concern with this installation is the risk of overloading the receptacles. While the wire is rated for the voltage and ampacity, and the receptacles are rated for the voltage, appliances plugged into the receptacles are likely to draw more current than the receptacle is rated for. This could cause the receptacles to overheat and create a fire hazard. The National Electrical Code, or NEC, specifies the ampacity of branch circuits based on the type of wire used and the number of conductors in the circuit. For a number 10 American wire gauge wire with 3 conductors, meaning hot, neutral, and ground, the ampacity is 30 amps under certain circumstances. However, when the wire is used in a branch circuit with more than one receptacle, the ampacity must be reduced. This is because the current flowing through the wire is divided between the receptacles, and each receptacle must be protected by a breaker or fuse that is rated for no more than 80% of the wire's ampacity. Several factors influence the ampacity of a conductor. These include the conductor's material, size, insulation type, and the ambient temperature in which it's installed. Different insulation types have different temperature ratings affecting how much current the conductor can safely carry. For example, conductors with higher temperature ratings, such as 90 degrees Celsius, are allowed to carry more current than those with lower temperature ratings, such as 60 degrees Celsius. The NEC provides tables, such as Table 310.15b16, to determine the allowable ampacities of insulated conductors based on these factors. Correction factors are applied when the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, as higher temperatures reduce the conductor's ability to dissipate heat. Adjustment factors are also applied when multiple current-carrying conductors are bundled together in a raceway or cable, as the heat generated by each conductor can raise the overall temperature and reduce ampacity. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overloads and short circuits. They are selected based on the conductor's ampacity and must not exceed the conductor's maximum allowable current carrying capacity. The NEC specifies requirements for selecting overcurrent protection devices in Article 240. Branch circuits are classified according to their maximum overcurrent protection. For example, a 15 amp branch circuit is protected by a 15 amp circuit breaker or fuse, while a 20 amp branch circuit is protected by a 20 amp circuit breaker or fuse. The type of load served by the branch circuit also influences the selection of overcurrent protection. For example, motor circuits require special overcurrent protection to handle the motor's inrush current during startup. Receptacles are rated for both voltage and amperage. The voltage rating indicates the maximum voltage the receptacle can safely handle, while the amperage rating indicates the maximum current the receptacle can continuously carry. Receptacles are available in various amperage ratings, such as 15 amps, 20 amps, and 30 amps. The selection of receptacles should be based on the intended use and the requirements of the connected equipment. For example, a 20 amp receptacle is required for appliances that draw more than 16 amps continuously. The NEC specifies requirements for receptacle installations in Article 406. These requirements cover topics such as grounding, tamper resistance, and weather resistance. Grounding ensures that the metal parts of electrical equipment are connected to earth, providing a path for fault current to flow back to the source and tripping the overcurrent protection device. Tamper-resistant receptacles have internal shutters that prevent children from inserting foreign objects into the slots. Weather-resistant receptacles are designed for use in damp or wet locations, such as outdoor areas and bathrooms. When installing electrical equipment, it's important to follow manufacturer's instructions and local electrical codes. These resources provide guidance on proper installation techniques, safety precautions, and applicable regulations. A proper installation can lead to electrical hazards such as shocks, fires, and equipment damage. Electrical safety is paramount to prevent accidents and protect people and property. Regular inspections and maintenance of electrical systems can help identify potential hazards and ensure that equipment is operating safely. Ground fault circuit interrupters, or GFCIs, are devices that protect against electrical shock by monitoring the current flowing through a circuit. If a ground fault is detected, the GFCI quickly interrupts the power supply, preventing a potentially fatal shock. Arc fault circuit interrupters, or FSIs, are devices that protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating heat that can ignite nearby materials. FSIs detect the unique characteristics of arcing faults and trip the circuit breaker, preventing a fire from starting. Surge protective devices, or SPDs, protect electrical equipment from voltage surges caused by lightning, power outages, or other disturbances. SPD divert the excess voltage away from the equipment, preventing damage to sensitive electronic components. In this case, a 25 amp breaker is protecting the branch circuit. If the receptacle is only rated for 15 amps, and an appliance draws more than 15 amps, the receptacle could overheat and create a fire hazard. Therefore, it is important to ensure that the branch circuit is properly protected and that the receptacles are rated for the correct amperage to maintain the safety of the residents and the appliances. Considering the information, a 20 amp breaker would be a more appropriate choice. However, the receptacle should also be rated for 20 amps to match the breaker. This setup would provide better protection against overloads and reduce the risk of fire. Using a 20 amp breaker with 20 amp receptacles ensures that the circuit is protected against overloads while also ensuring that the receptacles are capable of handling the load. This setup provides a balance between safety and functionality. Remember that electrical work can be dangerous and should only be performed by qualified individuals who understand electrical codes and safety practices. If you are not comfortable working with electricity, it is always best to consult with a licensed electrician. They can assess your specific situation and provide the best solution for your needs. Always prioritize safety when working with electricity. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Turn off the power to the circuit before working on it. Use caution when working in damp or wet locations. And never work on electrical equipment while standing in water. Following these safety precautions can help prevent accidents and ensure that you can work safely with electricity. The NEC is a comprehensive set of standards that covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The code is updated every 3 years to reflect changes in technology and best practices. Local jurisdictions often adopt the NEC as their electrical code, but they may also make amendments to address local conditions. Staying up to date with the latest version of the NEC and any local amendments is essential for electrical contractors and installers. This ensures that their work is safe and compliant with applicable regulations. Understanding the NEC can also help homeowners make informed decisions about their electrical systems. This can help them identify potential hazards and ensure that their homes are electrically safe.